The track shown in the figure is frictionless. The ball B is of mass 2m. Where is ball B? At the bottom of that hemispherical cavity. Can you see that? And ball A of mass m is pushed along the track. Basically, some guy is lazing around. Can you see that? Lazy day, quarantine period, what to do? Work is done, getting bored. So, he went and started taking a nap. This is an ingenious way to actually wake that guy up. So, basically what will happen is, the m in the picture will be thrown down with a velocity v. Guys, they are being shown as the bowling ball, but they are all particles for all practical purposes, okay? So, they move like particles, okay? So, you don't need to worry about how they roll. They move, translate, okay? So, somebody throws the ball m, okay? With what velocity should the ball A stop? So, somebody gives the velocity. What happens now? This ball comes down and collides with the 2m ball. Then what happens? Then 2m goes up and bangs the head of the person and he gets up. I know, pretty rude, but that's okay. Because what is the minimum velocity the 2m thing have to touch the man's head, to awake him? Well, just more than 0. The man should feel, kuch hai. That's all. Okay? So, all practical purposes, the minimum velocity of 2m to wake up the man is to become just 0 when it touches the man's head. Here is the physicality of the problem for you. Watch it. Goes down, collision, collision. Again, goes down, collision, collision. So, if I want, I can divide the problem into 3 parts. What are those 3 parts? Okay, ready? Energy conservation, collision, energy conservation. I'll repeat. Energy conservation, collision, energy conservation. Simple. So you have to apply K1 plus U1 equal to K2 plus U2 once. Then analyze their collision. Then apply K1 plus U1 equal to K2 plus U2 again. Simple. In fact, even the kinetic energy will remain. By the way, the collision is elastic, that's given to you. What's given to you is that the collision is absolutely elastic. So there is no Ke loss. But the problem is that the kinetic energy of the M block gets divided into 2 parts. That's the problem. That whatever kinetic energy M has right before the collision, that gets divided into 2 parts. Now 2M also has some kinetic energy, M also has some kinetic energy. Although collision is elastic. But elastic collision does not guarantee that individual kinetic energy will remain same. Elastic collision guarantees total kinetic energy remains same. Sum of all kinetic energies. Ready? Okay, sir. Here we go. Last time. All right. So first, it falls down with H, right? Let's say this instant, this point is A, this point is B, and this point is C. Whose energy are we conserving initially? I'm writing everything down. Let's say I choose my datum at B. So, gravitational potential energy at B is chosen as 0. So, Ka plus Ua is Kb plus Ub. Agreed? Whose energy I'm conserving? You can conserve only of one particle or both. Poor guy, the other one remains at rest anyway, so it doesn't harm you, right? Starts with half mv square. Sure, sir. Then Ua, mgh. Yes, sir. Kb is, let's say, half mu square. Any problem? U. Let the velocity be u. No problem. Right? And datum is, sir, datum is 0. Good. So u square is equal to v square plus 2gh. Any question whatsoever? So what is u? Under root v square plus 2gh. So far, is there a problem? What are we supposed to find, sir? We are supposed to find v. I know that. Hold on. First equation is clear? Okay. Now what happens? This is what happens. Let me exaggerate the diagram a little bit for you. 2m and m. You will solve this. Pen ready? Notebook ready? Okay. Give me V1 and V2. Give me just V2. Just V2. Only V2. Sir, how? Momentum conservation and E equation. You can choose left as positive. I'm giving you 1.5 minutes. Solve. Don't waste your energy. I don't want V1. I only want V2. Elastic collision. E equal to 1. Don't waste your energy. Only solve for V2. How will I solve, sir? Two equations. Momentum conservation and E equal to V separation upon V approach, which is equal to 1 in this case. Left side is positive. I am writing the equation down. You don't need to look at the screen. Now look at the screen, those who are done with it. V2 minus V1 is equal to U and 2V2 plus V1 is equal to U added. If you added, V1 gets cancelled. What do I get? Sir, you get 3V2 equal to 2U or V2 is 2U by 3. Are you guys with me so far? Take your time. So far, are we fine? Question is done now. We are done. If you want, you can finish the question off. This will lose its energy completely upon going to height h. Basically, very simple. Are we all convinced that V2 is 2U by 3? Sir, but you don't need V1? No, I don't need it. I don't need V1. What is V1 equal to actually? V1 is minus U by 3. It goes back with U by 3. I don't care. Why? Because it goes back with U by 3. It doesn't bang the guy's head who's sleeping. Who cares? I need to erase the board now. 2U by 3 is fine? Okay. 2U by 3 is fine. So all of us agree that 2U by 3 is fine. Okay. This 2U by 3, by the way, guys, is right here. And when it goes to C, it just touches his head. So, KB plus UB is equal to KC plus UC. KB, half. 2M. 2U by 3 square. UB 0. KC 0. Just touches there. Is equal to what? 2M. GH. Fair enough, sir. 2M and 2M gets cancelled. Don't they? What do you have here? You have 4U square by 9 is equal to 2GH. Right? If you want to simplify, that implies what is U square equal to? So 2 and 2 gets cancelled. U square is 9 GH by 2. U square is 9GH by 2. Now you know the drill. Equate. 9GH by 2 is equal to V square plus 2GH. So V square, 9GH by 2 minus 2GH. 9 minus 4, 5. 5GH by 2. V is entire under root 5GH by 2. Or 2.5GH, your call. This is the minimum value of V at which the guy gets up. What happens if the value of V is more than this? For sure it will get up. So this is the minimum value. Under root 5GH by 2 is the minimum value at which the guy gets up. Any value which is more than that. So V is more than under root 5GH by 2, or V is more than under root 2.5GH. Is that okay? Sure.